All right, today we're talking friction. So we've got a basic friction problem here. So let's just read it, draw it, and solve it. So we've got a box, has a mass of 10 kilograms. So I'll draw my best box, 10 kilograms. Oh, look, it's a box. It's being dragged to the right with a force of 35. So Fn equals 35. I guess it could have been tangent, but whatever. While also being pushed down with a force of 7. So we've got another force normal here of 7 newtons. Let's put newtons on that one too. Your mission is to determine the acceleration of the box. So we are looking for acceleration. So A equals question mark. So let's fill in the other forces. So 1, we're pushing up. We've got force of gravity here, which I'm going to write as mg because Fg equals mg. And then we're going to assume that there's friction, considering that the subject of this is how to solve problems with friction. So if we didn't have friction, that'd be kind of awkward. So now these two are balanced with this guy, and we are good with our force diagram. So now it's time to start solving some things. So first of all, if I want to solve for the acceleration's horizontally. So why not just solve summing the forces in the x-plane equals ma. And then we've got the force normal minus the force of friction equals ma. This force normal we know to be 35. So all we got to do is figure out this force of friction. So force of friction is unknown. Okay, I guess I can still deal with this. The mass is 10, and we don't know the acceleration. So right now we have two unknowns. And now I can go a little bit farther with this. All right, so I can go a little bit farther, and I can say that this is 35 minus, I can put mu Fn here, because friction is mu times the normal force equals 10 times my acceleration. And I'd have to know mu, and if I would have thought further ahead, I would have said mu equals 0.3. We'll just say that that's a true statement. All right, but this is still insolvable. So we could start crying, or we could go to the y-plane, because the normal force we're looking for is in the y-plane. So we can sum the forces in the y-plane, set that equal to ma. And so we've got a normal force pushing up. We've got gravity pulling down. We've got another normal force pulling down. And it's going to equal to 0 because in the vertical plane we have balanced forces because we have constant velocity. So I've got force normal minus 10 times 9.8 minus this downwards force of 7 equals 0. So now I can solve for this normal force. And when I solve for the normal force, I get the number of 105 newtons. So that's my normal force. So now I can take this and I can bring that into here, and then I can continue on. So now I can then do 35 minus the mu, which is 0.3, times the normal force, which is 105, equals 10 times my acceleration. So now I can solve for my acceleration. I get an acceleration of 0.35 meters per second squared. And that is how you solve for that. Now, the big mistake students make is they forget their on-by notation. Now, I didn't include it myself, but I'm going to put it in here now because it's kind of important. So if I look at my on-by notation, this is force normal on the box by the ground, and this is the force of friction on the box by the ground. So that's why these two are the ones that are linked when we're talking about calculating the force of friction, because the equation for force of friction is mu times the force normal, and this force normal is always the one that's perpendicular to the force of friction. All right, so that's why I intentionally put a bunch of normal forces around here to make sure that you could see I'm always looking for the normal force that is on the object by the surface that's creating the friction. All right, so sometimes it's more than one step. So here you saw I went through the X plane and got stuck. It's okay. Went to the Y plane, solved for some information, came back. That's cool. Maybe you might realize right out of the gate you're going to go straight to the Y plane, solve for that normal force, go the other place. So there's really no wrong way to solve this. All right, but that's how you solve a basic friction problem.